Hey everyone, so you're experts now on logs. You know how to evaluate them, you know how to expand them, and you know how to condense them. All of these tools will come together to do what we're doing today, which is solving equations that have exponential or logs in them. So let's get started. So the first and most important rule that you have probably learned through Khan Academy, and that I really need to stress, is that we need to get the log or the exponential by itself. So I'm going to go ahead and write this right on the top of the screen. Get the log or the exponential, whichever you have, by itself. Once you have it by itself, then you can switch over into the other form. So we'll be doing a lot of switching from logs to exponentials or exponentials to logs. So that's the goal. So the reason I mentioned that on this problem, remember we talked about the log x squared graph in our last video, that's going to matter a lot to realize what that graph can do if you mess with it, right? And we don't want to mess with it. So when I look at this problem, the log x squared equals 2, it's a very tempting thing to say, well, I know I can bring that 2 down. And you can. That is absolutely a legal thing to do. The problem is when you do that, you have now changed the graph and you've changed your answer as well. If I follow through with this plan, my next step would be to divide both sides by 2. So I'd get log x equals 1. And now since we're at the point that the log is by itself, now we switch into the other form. So just as a reminder, we'll write this at the top as well. When you have, we'll call it a to the x equals y, that's your exponential version. The log version will be log, same base. And then remember, the exponent's the answer. So that's what the log version of that expression or equation would look like. So for us to switch it into exponential form, the base is 10 because we don't see one. So we would write 10 at the exponent's 1, that's the answer, equals x. So we would say that x is 10. And we would think, hey, we solved it. We did everything right. We're good. The problem was, from the very beginning, the log was already by itself. So I'm going to solve this problem again, but this time I'm not going to mess with the log at the beginning. I'm just going to realize from the beginning the log was by itself. So let's switch it over into exponential form right now. So if I do that, my base is 10, so I will have 10 to the second equals x squared. So that means x squared is 100, right? But see what's about to happen? When I square root both sides, one of the things we always remember is you need a plus or minus. So look at that. There's my problem. Is it the answer 10 or is the answer plus or minus 10? So we probably aren't really sure at this point because it seems like we did legal math in both situations. This is where the graph will help us to answer what we should do algebraically in a situation like this. So what I did on the left side, basically, is when I brought the 2 down, I'm going to go ahead and graph that equation right there. So log x, we all know that graph. There it is. And 1 is a horizontal line. So yeah, in this situation, there is one answer. But remember, we were already on step 2 or step 3, depending on how you look at it, when we made this graph. If we actually graph from the beginning, this is what my graph looks like. Remember that because the x is squared, there will be the normal log graph on the right, but there will also be the mirror image on the left, because since x is squared, I can use positive numbers and negative. And then when I put the line through it at 2, what I see is there are 2 answers. So based on the original equation, the correct solving process is this one. By messing with the log, and I hate to say messing because what we did was legal, but it led us astray. So the correct answer is plus or minus 10. Answers, I should say, are plus or minus 10. So that's important to understand. That's also why you need to have an understanding of graphs, because when you solve with algebra, you have to get the same answer that you would get if you solved with a graph. And in this case, there could be a bit of a discrepancy. Cool problem, right? Yeah. Okay, let's go on. Okay, so here we have a log problem. And so the goal is going to be, because this is always the goal, to get the log by itself. So that's easy enough. The first thing I'm going to do is subtract 3 on each side. So I have negative log of x plus 2 equals 2. I'm still not at the point where I have the log totally by itself, so I need to divide both sides by that negative. And here we are. Okay, once you get to this point and you have the log by itself, now it's time to switch over into the other form. Remember, the base is 10, right? Because we can't see a number there. So we're going to write 10 to the negative 2, because that's the exponent, equals x plus 2. Okay, so 10 to the negative 2, that's 1 over 100. And now it's pretty easy to get our answer just by typing it in the calculator or just by knowing that the answer will be negative 1.99. Or however you want to write it, you can write it as a fraction too. So there's my answer. Perfect. Now you might be saying, but wait a minute, we can't take logs of negatives. So one thing we need to always remember about log equations, because log is limited, right? This log expression has parameters on it. That x has to be greater than 0. So I need to make sure that the answer I just found doesn't make me do something illegal. So let's check. So if x is negative 1.99 and I plug it in here for x, what will I have? Oh, well, I'll have log of 0.01. That's okay. So I'm going to keep my answer. It does not give me any kind of undefined result. So this is not an extraneous answer. All good. Okay, so now things get a little hairier. We have lots of logs. We have logs all over. And this is why we needed to learn those properties of how to move logs around before we could do any solving. So what I'm going to do is look at the left side and say, well, I could combine those logs together. And I look at the right side and say, yeah, I could do a little work there too. And I'm going to use those rules we've learned to kind of condense this into a smaller expression or equation. So I notice there is a plus sign in the middle, and we know that logs that are added mean multiply. So I am going to use my rule and combine these two into one log, where the two things we see, the x minus 3 and the x plus 5, are multiplied. Completely legal. On the right side, the one thing I see I can do is to move that 2 up to the top. That's an exponent for the 3. So 3 squared is 9. Now, I could, if I wanted to, subtract this log over to the left and then do a division. I could totally do that and it would be fine. But since I just got to the point where I have one log on each side, I can do an anti-log. Actually, what I'm going to do is put a base 10 on each of these sides. This is legal because that will cause the log and the 10 to cancel out. So what I have now is that set of two factors equaling 9. And in fact, I'm going to FOIL out the x minus 3 and the x plus 5. So here we go. So we have x squared plus 2x minus 15 equals 9. So we've accomplished what we wanted to, but in this case, a little bit differently. We didn't switch to an exponential form. What we did was to exponentiate each side, which is completely legal as long as you're down to one log on each side, which I was. So to solve this, it's a quadratic. We need to move that 9 to the left. So x squared plus 2x minus 24 equals 0. This is definitely factorable. So that will give us x plus 6 and x minus 4. So my two answers are x equals -6 and x equals 4. But this is where we need to go back and say, wait a minute, are these answers okay? So let's check -6. If I were to plug -6 in for this x at the top, I would be taking the log of -9. We can't take the log of -9. That doesn't even exist. -6 is not an okay answer. In fact, it would be bad in this other log as well because I'd have to take the log of -1, and I can't. Okay, well, let's check on 4 and see if 4 is okay. So in the first log, I would be doing the log of 4 minus 3, or the log of 1. That's okay. And in the second log, I would have the log of 9. That's okay too. So in this problem, we have one answer only, and it is x equals 4. And if you wanted to check that, you could graph this. You could graph the left side of the equation as y1, the right side as y2, and you would see these two graphs would meet at x equals 4. So a few interesting little nuances in this problem. We used our log rules. We used a little bit of a different strategy because we did that exponentiating on both sides, and then we had to check answers. So lots of good stuff in that problem. Okay, now this problem is always something that students look at and say, I don't even know, what am I supposed to do here? And what I call this problem is a quadratic in disguise. And you probably can't see it right now, but it's in there. There is a quadratic function hiding in this problem. And if you're not seeing it, first of all, notice there are 3 terms, so that's kind of a tip-off right there. Also, you're going to notice in the middle term, we have e to the x. In the first term, we have e to the 2x. And you're going to have to kind of get used to thinking this is e to the x squared. That's what e to the 2x is. So I'm starting to see this is kind of like a 2 something squared plus 5 something minus 3. I'm starting to see a quadratic happening. But for those of you who can't really see it yet, and that's probably many of you, what I do is a variable substitution. I'm going to say, all right, you know what? Let's just get e to the x out of the picture right now. And then let's rewrite the problem with y. So it looks more like algebra, what we're used to. So remember we said e to the 2x is actually e to the x squared. So that first term is going to be 2y squared. Then we have 5 e to the x, so that's 5y, minus 3 equals 0. Oh yeah, just algebra, just factor. Well, we hope it's factoring. Let's find out if this factors, and I think it does. So at the beginning, I'll need 2y and y. And then to get a 5 at the end, let's see, plus 3 minus 1. Let's check and make sure that works. And it does. Cool. So this was factorable. So my first factor gives me y equals 1/2. And my second factor gives me y equals -3. Okay. Now, that was all lovely, except remember, we're not done. When we're done, we will have x equals something. So we need to go back and remember that y is e to the x. So what I need to do is put e to the x back in for those y's. So we have e to the x equals 1/2 and e to the x equals -3. So it's kind of a two-step process. First, we take a look at the quadratic aspect of this. We factor and solve, but then we bring the e to the x back in. Okay, so let's talk about e to the x equals 1/2. We want to get x by itself. X is in the exponent, so that means we need to bring logs in to bring that exponent down. So remember, we're going to switch now into log form. Because this is an e, we're going to have a natural log of 1/2, and that equals x. And you just found an answer. Ta-da! That's awesome. And natural log 1/2 is a valid answer. You don't need to find the decimal for it because this is actually an exact answer. So natural log 1/2 is a better way to put it than a decimal. Okay, so now let's switch over and look at e to the x equals negative 3. Some of you probably already know the answer, but let's go ahead with the process we just did. So again, natural log of negative 3 equals x. But wait a minute, you can't take the natural log of negative 3. Natural log isn't defined for negatives. So for this part of the equation, we have no answer at all. But for the first part, we have natural log 1/2. Now, because the original problem was all exponentials, we don't need to worry about extraneous answers because you can put anything you want in an excuse me in an exponential. So the only answer we have is natural log 1/2. So we've now looked through some really interesting equations, and I've tried to point out some of the nuances and little tricky spots that can mess you up. Hopefully you're feeling really confident now and you can go forth and solve. See you tomorrow.